This meeting is being recorded.
For section 13.8, we're now going to take a look at how we can prepare these compounds that are called epoxides. So if you remember, back in chapter 8, section 11, you were told that alkenes can be treated with a peroxy acid. So that's what we see here, this peroxy acid reacting with an alkene with the pi bond, and we can form this epoxide product. So this is one route for creation of epoxides from alkenes, and this is a cyclic alkene. Specifically here, and the most common peroxy acids that are used, you're going to see this MCPBA, abbreviated for metachloroperoxybenzoic acid, and also we have peroxyacetic acid, right? Just those two carbons here. So these are the most common, and these can both be used to form epoxides with alkenes. Um, so you should also note that there's stereospecificity when it comes to creation of an epoxide, whether we have a cis orientation for our alkene or a trans starting material, we will result with the same in our product. So cis alkene becomes a cis epoxide, and of course a trans alkene would then become a trans epoxide. So take note of that there is that stereospecificity with preparation of epoxides. Another way to form epoxides are from halohydrins, and you can see that down here. So we have a treatment with a strong base here. So we have sodium hydroxide, and we'll walk through the synthesis problems or the synthesis process. But we can form this halohydrin initially from an alkene, and then using a base in a subsequent step, we can form this epoxide. So let's take a look on starting from the halohydrin here. We can perform a proton transfer by using that hydroxide ion to deprotonate our halohydrin, and then we have this alkoxide, more commonly, or more appropriately, we should point to this region up here, but this alkoxide ion that forms, and then through an intramolecular Williamson ether synthesis, we can form this epoxide here. So, so what happens is the alkoxide, the oxygen, this will act as a nucleophile and kick out that bromine as our leaving group here. So then we end up with this epoxide formation. So both routes are stereospecific, whether we form a halohydrin and then treat it with base, or we just use that peroxy acid, like the metachloroperoxybenzoic acid. Both routes, we would retain that stereo chemistry. So we have a cis starting material, we have a cis product, no matter which route we take. And we will talk more about reactions with our epoxides in the next section, section 13.9.